Hello everyone, welcome back to the series on programming robot mechanics. And in this video, we are going to write some unit tests of this link class that we developed in the previous video. Before going on to that, I realized after I made the video that I had missed a couple of things that were to be coded in this and made some mistakes that were quite visible. So let's first complete the missing things. So what we missed was str and repr, like the string and the representation functions. So let's just start with them first. Right. First, we will have the string function. And what we are going to do is first we are going to generate the string that will be outputting, returning. Okay. Right. So we can have we can first print the name of the robot. Then we can have an new line character. Okay. Then we can add to our string the DH parameters that we require. So we can do it in this way. We have the name. Right, let's take it in this way. Right, let's do it this way. So we can have a parameter. We'll add a tab new character over here, and then we'll add a value character over here, and then we will add a backslash n. Right, and then we can add something like this, tab backslash n. It will just create a line below the parameter and value. Then we can add the different parameters that we have, like alpha, and we can add backslash t and the value itself. Oh, we have to add this format character as well. We can print the alpha over here, string plus equals alpha a, and similarly the other values as well. Right, this is done. For now, let's just keep it this way, and right, let's add the join type as well. That should be the first thing that we should be seeing. String plus equals f join backslash t self dot join type backslash n, right? And then we can return the string. Right. Let's write the representation function now. I'll explain the difference after we have made this. Right. So these are two functions that we have. Okay. All right. The next thing that causes an error, let's see that in while we call this link function. Right. Let's create a main.py file over here. Okay. Let's import this. Right. From link import link. Let's we have over here. Okay. Let's create a link object, like just the default link object. This is a possible scenario that a user can have. Let's see what we get for this. Okay. YouTube. Let's set the individual environment. Right. One thing that I noticed, like I did not create a folder for the part 4, and we're just going in part. Okay. I'll create the folder later. No problem. Okay. Let's just go to part 4 over here. And okay. Let's now call Python main.py. Let's see what we get. Right. Now it says none type object has no attribute shape. And this is coming because first of all, we are taking the inertia matrix as a none type object. And then we are initializing inertia matrix using our setter method that we created in the previous video. Right. And it's trying to assert that inertia, the shape of inertia matrix should be 3, 3. But When we're initializing, the inertia matrix is a non-object and it does not contain any parameter called shape. That's what's creating the problem. So in the initialization part, we are going to put np.zeros as its initial value. And we're going to have the shape 3, 3. The same thing is going to happen for COG, but that is something that I also want to check, like what is going to happen for that. So first of all, we'll just assign it np.3. The same would have happened for COG, but let's see if your COG works after this change or not. Right, the shape of COG is incorrect because it should be, I think, 1, 3. I think it's either 1, 3 or it's, but let's just try and print it to see what exactly is the shape for COG. 3, right. So I think we can have this. Let's try what we get over here. Right, it's working now. So, okay. This is the complete class that we wanted to make. Now let's try and print the link. And okay, right. Let's just first, now the difference between string and representation will be clear. Now when we print, we have an error over here. So we'll need to see how we fix this. I think adding a double tab would make it work. I don't know. Let's see. Right, double tab make it work. Like, I won't say that this is the correct way to do this. A better way would also exist for doing this, like printing the things in a very ordered manner. A better way would exist for this, but for our purpose, I think this just works. And it's just giving out whatever we require, like joint is revolute, alpha is 0, AD, theta, all are 0. We can so on add other values as well, like the inertia matrix, COG, and mass. But let's just not use, since you're not using them in this video and some for the coming months, let's just keep it like this for now. Okay, now as you can see, using the print function, printed the str function. Now let's just have a link over here and let's see what this prints now. It didn't print anything. Okay. Right, let's try and print this. Class link. Okay, let me think. Okay, so in order to use the representation function, we need to enclose it within the representation tag. It's one way of calling it. Another way of calling this would be like this. But let's just do it this way. Right now, the name is missing because we didn't add any name for it. So it's something like this. Okay. And we're missing a couple of things over here. Oh, okay. So it didn't put that, right? Okay. No problem. I think we can fix it. Let's just, let's just fix it in a not so conventional way. All right. Now this works. Fine. So this is for the string and representation part. Now it's time to add some tests. For the purpose of this video, I'll just add the tests in this same file that we have, test.py. But in the near future, when we have a lot of classes, we are going to put all the tests in a particular test folder and then run them to just separate all the tests. Right. So from link, import link, right? And we're just going to have a single function over here, test link. And that single function is the transformation function. Right. What's the name of the function that we had? Transform. Right. Then we can create a link over here. Okay. let's name it body 1, and alpha value can be let's put an unconventional value over here since we are going to test. A equals 0.1, d equals 0.1, and theta is not required for our purpose. Okay. And then we can have the transformation as link. Okay, so we're going to have two tests actually. One is for the theta one, and one is for the A that is going to change, right? Okay. So we are going to have an Excel, so let's just keep it over. Link dot transform, and let's add the theta value to be np dot pi pi. Pi pi. Okay. Now, how are you going to calculate the actual transformation? Let's see how we're going to do that. Right, now to test this function, we need an actual transformation as well. That we are going to derive from MATLAB, like the previous video that we made. Okay, first thing, now the procedure to do this in MATLAB is a little bit lengthy, not exactly lengthy, but it is a little involved and a little different from how we have developed the library. First thing that we're going to do is add a rigid body, that is body 1. Any name would done over here. And then we have, right. And I am using this link over here. I'll put the link in the description. Like I'm using this link to see the MATLAB functions that are there. Right. And then, we are going to add the rigid body joint. Its name is this, and we're going to have a revolute joint, just like we have in the test. Right, it's done. And then we can add, right. Now we're going to set the home position to pi by 2. This is like the test that we're going to do. Okay, I need to put semicolons. All right, and then we'll call the set fixed transform function. Oh, okay, let's add some space. Okay, we just add over here. Okay, then we can add set fixed transform to joint 1, and we are going to add the DH parameters over here and a parameter called MDH. What MDH is, there are conventionally there are two types of DH parameters that are used by roboticists. These are the simple DH parameters, and MDH that we have specified are the modified DH parameters. Well, the transform that we developed in the previous video, this is a modified DH parameter formula. That's why for testing, we are going to use the modified DH parameter over here. Right. Now let's fill in the DH parameters that we have over here, and the order is A alpha D theta. Right. A is, I remember, 0.1. 0.1 is alpha. Okay. Alpha is pi by 3, and this is 0.1. D is alpha, A alpha D theta. Theta is not going to be interpreted as such because it is a revolute joint. And then we have fixed the transform. Okay. Now to the next step. The next step is to assign this joint to the body that we made. Okay, we are done with this. And then we define a robot class. Now, we are going to develop this robot class later towards some videos, but for testing, we need this over here. Right, we added the robot. Now we're going to add a body, the same body that we developed. To robot body 1 to the base. Right. Now comes where we are going to print the transformation. First of all, we're going to get the home configuration, the value that we set above for robot. And then we're going to get transform robot config body 1. So this is the matrix that we are supposed to get. Right. Let's just copy it. Right, this is done. Let's test it now first. And then we will start working on the prismatic joint as well. Okay, so it failed. Let's see. 0 minus 1. Oh, I think we didn't. Oh, right. We did not add the decimal part over here. That's why. Right. It runs okay. Now for the prismatic joint, it's going to be very similar. So I think I'll just fast forward through it, like how we get the joint value over here. Right. Okay, so I think this is very similar to the one that we had before. It would be good if we can just copy it right away. 0 minus 1, 0. No, it's not the same. No. Right, it's not the same. So I can copy it right away. Let's just copy it like this. Right, let's understand. Right, so that is 10, okay? And this is exactly the matrix that we got. Right, now we have tested the theta parameter. We have tested the A parameter as well. We tested the string and representation as well. So I think this is it for the link class. If I cannot, yeah, I think this is pretty much it. So in the next video, what we're going to do is we have made the link class, but before doing its visualization, I think we can first create a robot class and then we can go on to the visualization part. It will, I think, be better in a sequence like this, but let's see what we get. So, right. See you in the next video then. Bye.